Guys, thanks for sticking with me to this last video. Sorry, it's a lot of information, but this particular lesson just has a lot of vocab. Okay. I am just devouring these chocolates. I need to stop. Okay, moving that away. So, last two things: mutually exclusive versus overlapping events. Basically, what this means is, for mutually exclusive, it means that both events cannot happen at the same time. For example, if I were to randomly select a student in school, what's the probability that they're going to be a freshman and a sophomore? 0. That's not possible, right? Okay, you're either a freshman or you're a sophomore or you're a junior or senior, but you cannot be both. Don't try to argue with me about, like, what about the summer? No, it's not possible, okay? You either are or you're not. Overlapping events is the opposite. So both can happen at the same time. So for example, if I were to select a random student again, what's the probability that they're going to be a freshman and they're going to be in vocal? Is that possible? Of course it is. You can have freshmen in vocal. Okay, you can have all of that. All right, so what does that mean with our formulas? Well, if I'm saying that mutually exclusive means they cannot happen at the same time, that means if I'm saying this and this for mutually exclusive events, the probability is 0. Okay, so for mutually exclusive events, the probability of A and B, I'm going to use a different color, probability of A and B is 0, meaning it cannot, both events cannot happen at the same time. Okay, remember that this means and. The intersection is and. But then there's another formula that you need to know. What if I want the probability of this or this? Okay, so the probability that I'm going to select a student who is a freshman or a sophomore. Could be one or the other. So to get that probability, you just take the probability of the first event and add it to the probability of the second event. So the probability of A union B for mutually exclusive events, remember union means or, is the probability of A plus the probability of B. Okay, we will do examples, hold on. Comparing that over here to our overlapping events, there's nothing really special about the intersection. You just have to look at the options and see how many there are. To have both, like, for example, how many freshmen are in vocal, you would take that number on the numerator and divide it by the total number of students surveyed, and that would be your intersection. The union, though, has a special property. So there's a special formula here. Thank you, Miko. Where I can take the probability of A union B, or if I'm looking for, the probability of A union B, I take the probability of A plus the probability of B, but then here's where it's important. You have to subtract the probability of A intersection. Remember, that means and B. So it's kind of a weird combination here. Probability of A or B is you take the probability of A plus the probability of B, but then you have to subtract the intersection. And that is because they are overlapping, right? If you use the freshman in vocal example again, if I wanted to figure out what's the probability that I selected maybe out of 100 kids that they were a freshman that they were a freshman or that they were in vocal, right? That's the union there. Then I would take, okay, how many freshmen what's the probability of getting a freshman plus the probability of choosing someone in vocal, but there's a certain number of students who are both freshmen and in vocal, and you don't want to count them twice, right? So if you just said, let's say the probability of, I'm going to make up some numbers here. Freshman class, I think, was, well, we're going to use the 100. So let's say out of 100 students selected, there's only, I don't know, I just have to make things up. Let's say there's only 20 freshmen out of 100. Then you want to add that to the number of vocals. So let's say there's 10 kids in vocal out of the 100. But out of these two numbers here, the 20 and the 20 and the 10, there are 5 freshmen that are in vocal. Well, I already counted those 5 in this freshman count, and I counted the same 5 in the vocal count. So I need to subtract away one of those. So subtract this 5 out of 100. Okay? If that made no sense to you, never fear. I have better examples, and these examples are actually going to be from your homework. So let's do them together. Okay? All right. What is the probability when you roll a die of getting an odd number or getting a number less than 5? Okay, so what you want to ask yourself is this mutually exclusive, or is this an overlapping event? So if you think about it, you're just asking yourself, can both of these events happen at the same time if you were to roll the die? Right? So meaning, are there odd numbers that are less than 5? Yes. So this is an overlapping one. And we're dealing with the or the union, so that's going to be this formula above here. So the probability of odd or less than 5 is equal to, let's plug it into this formula right here, the probability of the odd plus the probability, the probability of getting less than 5, and then subtract the probability of odd and less than 5, the intersection. Okay, so let's back up and do each of those. Let's start with, I'm going to color code here, probability of odd. All right. Well, if you have 6 numbers on a number cube, then the probability that you're going to get an odd is going to be 3 out of 6, which is 1/2, right? So I'm just going to write that here, 3 out of 6, which is 1/2, okay? Now, what's the probability of less than 5? So that's 1, 2, 3, and 4. That's 4 options out of 6, okay? That's going to be 2/3, right? Okay, so the last thing is, what is the probability of getting both a number that's odd and a number that's 5? Okay, so if this is the part you struggle with, which most people is, you can always write it out. Here are my options. I can get a 1, a 2, a 3, a 4, 5, or 6. What's the probability, or let's just think about how many options are there that are both odd and less than 5. So that eliminates 5 and 6 because it has to be less than 5. And we want to eliminate the even numbers, 2 and 4. So the probability is going to be, you have 2 options out of 6, which is 1/3. Okay? Now, I know I'm simplifying each of these, but actually it's going to be a lot easier for you if you don't simplify until the end, right? So I'm actually going to take this 3/6 here. Here, let me continue my coloring. 3/6 plus 4/6 and subtract 2/6. All right, so again, let's not simplify until the very end. So ignore my simplifying right there. And that's because if you were to simplify, when you're adding and subtracting fractions, remember, you cannot combine them if they don't have the same denominator. So since these unsimplified all have the same denominator, 3 plus 4 is 7. 7 minus 2 is 5 over 6. Can I simplify that anymore? Definitely not. So that's my answer. Woo! That's fun. I know. You thought it was fun. Okay. So again, you want to ask yourself, are they overlapping or mutually exclusive? And that will help you narrow down the formula to use. Okay. You can also think about it logically. A lot of people don't like to use these formulas. But if you're having trouble narrowing it down, then the formulas are always a good way to go. All right. Example 9. What is the probability of spinning a brown or more than 8? Again, this comes from your homework, so I would suggest doing Pearson while you're doing this. Okay, so ask yourself, are they mutually exclusive or overlapping? Meaning, can they happen at the same time? Can I have a brown that is more than 8? Let's look at the picture. You got a brown 5, a 3, a 7, a 4, and a 6. Well, none of those browns are more than 8, right? So this is actually mutually exclusive, which helps me narrow down my formula. So let me go back up to my formula. Here it is, right here. The probability of A or B is just the probability of A plus the probability of B. Okay? Probability of A or B is the probability of A plus the probability of B. Okay, so A is my brown, B is my more than 8. So what I'm really doing is I'm trying to figure out the probability of brown or greater than 8, which is going to be the probability of brown plus the probability of more than 8. So let's do the brown one first. Probability of spinning or landing on a brown looks like it's pretty even because there's 5 browns out of 10 options. Again, let's not simplify quite yet. Let's do the 8 in this color. So we want to count up how many options are there that are greater than 8. So that's going to be, looks like it goes to 10. So there's only 2 options, the 9 and the 10, out of 10. All right, and then you just add them together. Okay, 5 plus 2 is 7. 7 out of 10 does not simplify. So that's my answer. That one's easy. Mutually exclusive is pretty easy. Okay? All right. We're not going to worry about this example here. I was going to show you some Venn diagrams, but it's not on your homework, so let's not worry about it. All right. Thanks for hanging in there. You guys are the bestest. I'm going to go eat some more chocolate now. Bye.